This interesting equation is used for climate modelling. It tells us about the temperature of the Earth based on these variables. And you should chat to your science teacher to find out more about it than I'm going to describe now, because here I'm just using this equation as a way to practice our algebraic fraction skills, a little bit of our index laws, and see how being able to work with an algebraic fraction can give you a window into understanding a formula better. So, instead of putting in values for each of these variables, which is what we would do if we wanted to know the value of the temperature, we're going to substitute in the units that the variables are measured in so we can see what units the temperature is in. Because temperature might be measured in degrees Fahrenheit, degrees Celsius, or degrees Kelvin. And if you haven't heard of that last one, once again, have a chat to your science teacher. That's just a 1, no units. This is the albedo, or how much energy is reflected back from the planet Earth. So it doesn't have units either. This is the power that's coming in from the sun, and it very much has units. Again, chat to your science teacher, but it's watts per metre squared. This is the Stephen Boltzmann constant, and to sum it up, it helps us calculate how much heat the Earth is giving off compared to how much it absorbs. So it's measured in units that look fairly complex, but have a little chat to your science teacher, you'll find out it's not so bad. That's a 4. This is the emissivity, a little bit like that. It doesn't have any units of its own either. So at this point, we've taken the original formula, and for any of the variables that had units, we've substituted them in. Now we're going to stop looking at this as a formula, stop looking at this as units, and just have a look at them as though they were pronumerals. So if they're pronumerals, there's a nice clear common factor. Simplify. And again, there is a nice clear common factor. M to the negative 2 simplifies with m to the negative 2. 1, 1. Means that we're left with 1 over k negative 4. All to the power of a quarter. So, using your index laws now, most sensible thing would be to rewrite this as a positive indice. And final step, apply the index law for powers of powers. 4 times a quarter is 1, or simply k. So what we've done is reveal that this temperature here is measured in degrees Kelvin. Chat to your science teacher, see what that is. But this is an application of your algebraic fractions skills. Bye.